Hello. Today we're going to do a series of mini demonstrations showing the relationship between electricity and magnetism. Ørsted in the mid-1830s completed a number of experiments that clearly show that there is a connection between electricity and magnetism. And we all know that a magnet has two poles. It has a plus and a negative. We all know that opposite poles attract and like poles repel. We're going to show you things related to that. We also know that you cannot pick up a copper wire, use a copper wire, with a magnet. It just is not magnetic. Copper is just not magnetic. So that is part of the fascination between the connection between electricity and magnetism. For this first demonstration, I have a magnet on a pivot. It can rotate around. In fact, it's basically the same as a simple compass, which is a bar magnet on a pivot, and it can rotate around and points into the Earth's magnetic field. This has too much friction to be guided into the Earth's magnetic field. The Earth's magnetic field is not very strong. This has an almost frictionless pivot. It's balanced on there. It's a simple compass, and it will point to north magnetic pole and south magnetic pole. Now on this pivoted bar magnet, I have an identical bar magnet, except it's not labeled north and south, as you can see. But what I can do is, this right-hand portion is north, this is south. Watch what happens when I put the magnet one end near one of the poles. Oop, it attracts it. So therefore, this must be the south end of this magnet. Otherwise, if I turn it around and I take the north end and I point it, look at how it moves it away. It repels it. It repels it with an equal amount of force. Now, if I could somehow make these fields repel and keep repelling, I could make this go round and round, and I would have basically a motor. But as we know, motors just don't work in this way. We do have magnets repelling other magnets, but they're electromagnets. And the next mini demo is going to show that. The next thing that I'm going to show you is really cool. We have two bar magnets, and as you can see, they're labeled with south and north poles. If we lay them on the table and just push them to each other, one wants to turn around, boop, boom, and they want to stick together with the south and north touching each other. But if I turn them like this, and I'll start over here, and I push the two north and south poles together really evenly parallel, so the forces are building, feel the force building up, it'll shove the other magnet away. This is how maglev, or magnetic levitation, works, except that this magnet would be on top of this one, and it would float the car. This is how it moves. Look at that. It's an invisible force between them. 3. Here's another really cool demonstration. These are all small compasses. That's floating bar magnets. Watch what happens when I bring a magnet near it. This is the bar magnet I was just using. I can bring the bar magnet, so I get my hands out of the way, and you can see how all the needles start to line up. But if I turn it over, the needles reverse themselves, and they would. Okay, now this is very good to demonstrate magnetic resonance imaging. In an MRI, the little water molecules in your body, of which most of your body is made, they will flip over in an oscillating or changing magnetic field. And when they flip over, they give off tiny little amounts of electricity, which can be picked up with very sensitive coils, and a computer can then take that information, digitize it, and turn it into a picture of how many water molecules are in different sections of your body so that we can see tumors and things like that. And of course, you don't feel an MRI because you don't feel magnetism. It's really neat to show that demonstration. Okay, in this demonstration done by Orsted, we're going to show you the connection between electricity and magnetism. Now what I have here is a 9-volt battery and a clip lead attached to one of the poles. I believe this is the plus pole, and the wire runs under a very simple little compass, and then it runs around, and I will connect it. I have it separated to the other end of the battery to make a short circuit. The electrons will run under the compass, but they will not touch the compass. Now I'm going to close up this compass so that you can see it. You won't be able to see me touch the wire to the other end of the battery, but watch what happens when it does. It not only spins it around, but it had enough force. If I do this right and touch it a number of times, I can spin that around all the way. What we have here is electricity moving electrons, actually generating an electric field and inducing it into the magnet, the fixed magnet. So Orsted showed that electricity and magnetism are connected. It produced the electricity, the moving electrons produced kinetic energy in the needle. And we were even able to show you with this one. I was just going to deflect the needle and then have it deflect back. But by touching the other pole with the wire, you can see here, I could make that magnet go all the way around. I have a very simple electric motor, the granddaddy of all electric motors. In our final mini demonstration, we're going to show how a generator works. What I have here is a coil of wire with a hole in the middle. It's just a couple of hundred turns, if that. It would work much better if it were more turns of wire. The ends of the coil right there are connected to clip leads, which are in turn connected to each side of a electric meter. If the current runs one way through the meter, the needle will deflect or move to the right. If the current moves the other way, the electrons are moving the other way, the needle will deflect or turn to the left. So what I'm going to do here is I'm going to thrust a magnet in and out of the coil, and you can see as I thrust the magnet in and out of the coil, the needle seems to be moving. Let me focus in on that. Get the close-up of the meter. You won't be able to see me put the magnet in and out very well. Maybe if I hold it up like this. Yeah, see? As I put the magnet in and out of the coil, if I just rest the magnet in here, this is a very powerful neodymium magnet that I have on the end of this other little magnet. This one here, will, if you move in and out, you can see if I move the magnet into the coil, the needle moves to the right. If I move it back out, the needle moves to the left. This is how all generators, including the alternator in your car, work with a magnet that goes in and out. So now we've demonstrated how Orsted showed that magnetism and electricity were indeed connected. In fact, we know now that they are two sides of the same force. We call it electromagnetism or electromagnetic force, and it is used for every electric motor and just about every electronic device in existence today. Thank you very much for seeing the demonstrations.